Very good morning. I am Dr. Senthilkumar, Associate Professor in the Department of Agricultural Engineering, SNS College of Technology, Coimbatore. And I welcome you all for this lecture series for the month of February 2024 for the course Farm Mechanization. And this is the fifth video of the lecture series. The topic that we are going to discuss in this video is the field capacity, efficiency and economics of machineries. That means machineries, what all we are using in case of farm operations. What about its field capacity, its efficiency as well as economics we will discuss in this video. Now to separate terms related to field performance of machine. Theoretical field capacity is to take into account. It is the rate of field coverage of an implement that would be obtained if the machine will perform its function 100% of the time at the rated forward speed and always cover 100% of its width. The formula to be calculated is W/S by 10 theoretical time per hectare. It is a time that would be required at the theoretical field capacity. And to say about the effective field capacity, it is an actual average rate of coverage of the machine. It is expressed as hectare per hour. So C equal to W/S by 10 into EF, that is efficiency. So where C is the effective field capacity in terms of hectare per hour or acres per hour, we can take into account. W is the rate of width of the implement in terms of meter or in terms of feet. S refers to the speed of travel in terms of kilometer per hour or in terms of mile per hour, and EF refers to the field efficiency in terms of percentage. Thus, effective field capacity on the basis of total minutes per hectare is the sum of the theoretical time per hectare plus the time per hectare required for turns plus the time per hectare required for support functions. That is the time lost as a result of adjusting or lubricating the machine, breakdowns, cloggings, turning attendants, adding seed or fertilizers, unloading of harvesting products, waiting for a crop transport equipments, as well as the effective or actual capacities will less than the theoretical or potential capacity. We know this very well. When we are calculating the theoretical capacity, it will be more, but the actual capacity will be slightly reduced comparing with the theoretical capacity. And to say about the effective operating time, it is a time during which the machine is actually performed its intended functions. And to say about the field efficiency, the ratio of efficiency, effective field capacity to theoretical field capacity in terms of percentage. It includes the effect of time lost in the field and failure to utilize the full width of the machine. And to say about the performance efficiency, it is a measure of functional effectiveness of a machine. Example, the percentage recovery of useful products by the harvesting machine. Field machine index, it is the percentage ratio of effective operating time plus turning time. Both is to be included to calculate this field machine index. And to say about the comparative index, it is determined by actual time studies with same machine for different fields. Considering for the same machine at various fields, we can go for this comparative index. And to say about the time efficiency, it is the ratio of time of a machine is effectively operated to the time a machine is committed to operations. Following list describes the time elements that should be included when computing the capacities or cost of machine. There is machine preparation time at the farm shed, travel time to and from the field, machine preparation time in the field both before and after operations, that it includes daily servicing, preparation for towing, etc. Theoretical field time, that is a time the machine is operated in the crop at the optimum forward speed and performing over its full width of action. Turning time and time crossing grass waterways, that is machine mechanisms are operating. Time to load as well as unload the machine, if not done on the go at this part when we are starting, we will do these operations. And to say about machine adjustment time, if not done on the go. Maintenance time, that is refueling, lubrication, chain tightening, if not done on the go, not include daily services. Repair time, time spent in the field to replace or renew parts that has become inoperative. So these all things is to be taken into account. That is factors affecting the field efficiency. Theoretical field efficiency capacity of a machine. Field efficiency decreases when increasing TFC, that is increasing the width of 4-row implement by 50% will increase the effective field capacity by 35% for planter and 40% per cultivator, and with increase in operating speed of the implement. So whenever the speed goes on increasing, its life is getting affected. And machine maneuverability, farm machines need to be easily maneuvered in fields and on the roads to the fields. Field machines need to be designated to make sharp turns at the ends of the field and while following crops row patterns on the contours and in curves. Field tillage or seeding machines can make square turns, rakings and windowing and or baling operations usually follow a rounded come patterns. To sabotee various pattern, that is field patterns, objectives or amount of field travel should be minimum. Number of non-working turns should be minimum. Number of non-working travel in interior field should be minimum. Field patterns should produce level surface to eliminate water ponding. Repeated machine travel over a particular area of field will cause compaction of soil. To sabotee field shape, an irregular field has a less field efficiency than rectangular field because of excessive turning time. So to sabotee field size, field efficiency of large field is less compared with the less size field. And the yield, in case of if harvesting operation, if yield is high, it changes the width of cut of the machine throughout capacity of combine approximate to 10 ton per hour. 50% of crop load. Crop and soil conditions. If crop and soil conditions are poor, machine forward speed reduced, field efficiency will improve, but this is not a desirable factor. To sabotee system limitations, field efficiency may be limited by capacity of other operation systems. Example, seedbed preparation and planting is a system in which seeding is required immediately after the soil preparation. Seeding can be done 1 acre per hour, but seedbed preparation can't do like that. This harrow 1 pass acres per hour. And to sabotee mechanization terminologies, selective mechanization, use of machines or equipment for selected operations only. So generally in case of mechanization, we will give the definition as application of machineries as far as possible in all areas of farm operations. To sever selective mechanization, only in case of selected applications we are going for application of machineries as well as implements. So low cost mechanization is cheap as well as affordable. Tools, gadgets and equipments with cost less and can be fabricated by village artisans and small scale industries itself to be taken care. To save a tool, it is a simple mechanical or electromechanical devices to perform a task. An individual working element of a machine such as disc, shovel, cutting blade is also known as a tool. To save an implement, it is equipment which with no moving or driving parts such as plough, cultivator, harrows. It contains rigid structure with working tools. And to separate machine, it is a combination of rigid bodies with linkage, executing specified motions and performing desired task. And to say about equipment, it is a general term used for any tools, implement or machine or gadget. So all comes under the category of equipment. To say about device, any mechanical which offers mechanical advantages. We can say gadget, small or relatively simple tool or machine is called gadget. And to say the type of implements, there are various types. Pull type or trailed implements, it is pulled and guided from a single hitch point and is not completely supported by the tractor. And to say about the mounted implement, it is hitched to a tractor through a 3-point linkage in such a manner that it is completely supported by the tractor when it is in raised position. The linkage provides the rotational stability about the longitudinal axis and permit depth or height control by vertical support from the tractor. And to say about the semi-mounted implements, it is attached to the tractor through horizontal or nearly horizontal hinge axis and is partially supported by the tractor at least during transport, but it is never completely supported by tractor. In heavy and large semi-mounted implements, supports wheels at the rear or in the middle together with remote hydraulic cylinder, which is utilized for raising and lowering the complete implement machine or its individual units. To separate self-propelled machines, one in which propelling power unit is an integral part of the implement as well as machine. And to say about the advantages of mounted equipment, it is less expensive than the equipment that is pull type equipment. Support wheels and accompanying structure require a pull type equipment is eliminated. Single depth or height control system forming a part of the tractor. And to say about the limitations of the mounted equipments, carrying capacity of tractor chassis, transport stability is a limitation. And to say about the advantages of self-propelled machine, it is a greater flexibility, better visibility, better control of operator, improved mobility. And to separate disadvantages, greater initial investment, Since it is a self-propelled one, the investment will be more comparing with the other types of implements. It must have a high annual use to be economically competitive with the pull type machines. So thank you for watching this video. That is the video 5 series video of the course Farm Mechanization. Thank you.